Let's take this idea of exponents and apply it to a real world situation. So, this first problem that we're doing, it says in a biology lab, 500 bacteria reproduce by splitting. Every hour, on the hour, each bacterium splits into two bacterium. So, what we're going to do here is we're going to take this idea and we're going to put it into this table. So, to start off, we have 500 bacteria. Now we know that at hour number 1, then it's splitting. So we're going to multiply it by 2. We had 500, they're all splitting. We're going to multiply by 2. In the next hour, we're going to take what we got from this one and we're going to multiply by 2 again. After that, we take 500 times 2 times 2, whatever we got from number 2, and we're multiplying what we got by that to the times 2 again. Before we go to 6 and we write out a bunch of the number 2s, let's think about what each of these mean. How could we rewrite 500 times 2 times 2? Think about the exponents that we were working with. A way that we can do this is we can say 500 times 2 to the, and we'll even just put it to this second power, because we're multiplying 2 times. Here we have 500 times 2 to the 1, 2, third power, 3 power. Notice that those numbers that we're using, so to the second power, was our input for the hour. That 3 was our input for the hour here. Think about how can we write something to the 6th hour? How would we write that? For that, we're going to put 500 times 2 to the 6th power. Now consider, and here we could even put to the first power. Remember that 1 is assumed. Now consider what we would write for something to the t power. How could we write a general equation when we have something to the t power, when our hour is an unknown, is that variable t? We would simply write it as 500 times 2 to the power of t. So what we're going to do now is we're going to take this idea, we're actually going to solve for the number of bacteria, and then we're going to use that information to create a graph.